Okay. Hello, and yes, welcome. Welcome for today's event. And my name's Aaron, and I'm an event host and helping with the tech for the events here at Goto 10. So glad to see you all here tonight, and I know it's going to be a great event, and so it's nice to have everyone. And just a little bit about Goto 10. You know, obviously we're an event space, and you know we are a co-working space, and it's free and all. We have all that, but we're much more than that. And I think you know that this tonight's event showcases just what Goto 10 is really about, because we have Thomas here, who is one of our great members, and he is doing so much for the community here at Goto 10, and on his own initiative, working with Oli, community manager, and yeah, just putting a lot of great content out there. And I think this is just a great demonstration of what the potential is for Goto 10, and so great that you're doing these events, and we hope you get a lot of value from this as well, and maybe inspire you if you want to do your own events. And you're very welcome to join the community if you want to find out more about Goto 10, if you want to see the place and see what we have to offer. You're very welcome. But I'll stop talking and pass you over to Thomas. I just need to switch your mic on, but I'll do that right now, and then you're good to go. So.
Hello. Here we go. All right. Good evening, guys. I'm Thomas, has just been introduced so kindly by Aaron and Oli. We're here in quite dark Sweden, but let's light up this night and get cozy and creative and see what we can do with 3D printing. So, myself, I'm come from Toyota Group, and I'd worked in many of our subsidiaries with cars, trucks, robots, and so on. At this point, I belong to TMHE Design Center, where we have our outpost in Mjölby, Bologna, as well as Gothenburg, so we're quite international. We cater our European clients, and yeah, we brought one of our printers in here. We're partnering with famous printer producer Prusa. They will join with us around 6 o'clock, so this is going to be a live session. You guys can ask questions, you can interact. Later on, if we still got time, we can see if we can produce some narrative designs to go from speech to text and 2D to 3D, but if time allows that to us. So the program in the beginning will be just introduction of the printers that Goto 10 owns. That's Flashforge Adventurer 3 and 4. So as also requested by our managers, a lot of the people are using them without some expertise and knowledge, and then they break often, so we'll just go through that. Everybody can enjoy this, be creative. So you print more, we're more happy. You print more, you leave less waste, less broken printers, more smiles, you know, something like that. So to begin with, I'll just go with the setup of slicers, which is, I think, so important. And I think both companies have excellent platforms, and we'll just start with Flashforge. So example, we're now connected to the Adventurer 4, which is the bigger machine, and why is it perfect for a place like Goto 10? Because it has an enclosure, it's so friendly to use, and yeah, it has also movable beds, and this is the actual bed, which you see we got. This is the good example. You know, we printed a benchy, which turned out actually pretty good, I think. You can like pass it around to see. A benchy is a 3D printing industry's benchmark to see how good it prints. And we got left all this residue. You see, like green stuff. Normally, people don't care, shove it back, and then next guy, if he prints from the cloud, he can't see that. Yeah, I mean, he can go to the camera and there and check, but if he doesn't, we're done. So usually what we have, and you'll be like, oh my God, this guy is boring, you know, he's going to maintenance already. But why it's so important? Without this, you will never get bloody anything. Because the way the printer works, it needs a completely flat bed. If it's a little bit off, we're done. I mean, we can't go and continue. And like with this one, it's also a good example. It's stuck pretty bad. We also need something metallic, even, I would say. Yeah, so we carefully can pick up a small screwdriver and see that we don't damage it. Do it with a due diligence, you know. Sorry? Yeah, it's a good one, yeah. So it's a good question, yeah, actually. I mean, the print bed, this one.
Yeah, so I was just wondering what the material is. I know the Prusa is some kind of PEI sheet, but...
Right. So this one, it's just a textured sticker on what seems to be a steel plate. Since these are pretty much very hobby scale printers, they use much more simple stuff, you know, so nothing fancy. These are very much replaceable, you know, you can just buy new stickers and put them back, yeah. So,
all right.
So yeah, so we do this, and then what's important? We touched it all like 1,000 times now with our fingerprints. It's really important to spray the alcohol and to clean it up. Just, yeah, because it won't stick, you know, it's what it does. It won't stick, and then, yeah, you really need to line it there, and what happens often you don't. And, yeah, I mean, these Flashforges, they're a bit fiddly. I'll give that to you guys. They're quite, yeah, Prusa's much more like prosumer, but these are, how to say, more forgiving, but same time at some point, yeah, it gives out. So yeah, the cool thing, we can print, yeah, from the cloud. So you can just sit somewhere comfortably on the 3rd floor, check on a camera, it's free, boom, press, print, it goes, you know. How cool is that? You know, look, we're doing a second benchy from the comfort of our seat. And if we look in there, we can even find a camera somewhere, I believe. Camera is turned off. Here we go. Let's see if it will ignite. Usually it does, like after a bit. Okay, so we got the first one. So the cool thing, it got the connection on Wi-Fi. You can also just come and slice it with. Oh yeah, the camera is on. Actually, we can see it even ourselves. So we'll see it live when it starts, which is, again, it's extremely comfortable, because yeah, if not, it's just I can hear every breath, you know. All right, so yeah, it's just good to avoid all these spaghettis. What are spaghettis? It's obviously when you didn't do some preparations, spaghettis will be extremely evident. Now there's cool apps like 3D Print, Honey, and so on. They can automatically detect your spaghettis, shut the thing down so you don't waste your material and you don't run into the risk factor of burning your printer or house, which is very rare. But they always advise, like, keep an eye on your print. Like, if there's a big ball of spaghettis and it gets under your nozzle, and nozzle is this thing, like, in case of Flashforges, they got easily replaceable ones. Just go there, you pull it out when it's cold, and yeah. But if there's a big spaghetti, there is a chance that PLA or other low temperature material can catch on fire. There are, though, I think Hassel will introduce like a Prusa, and they introduce now materials which are V0, so they can catch on fire while printing and while being used in electronics. So this baby heats up to 240 degrees in order to deposition the filament. So you can imagine this is pretty hot, you know, like, so it doesn't catch in open flames naturally, but potentially it could, and we don't want that. Yeah, there we go. We got one more of them going for the first layer, and yes, it's all right. Yeah, it's just going there. It had some debris on the nozzle, but still, it. So the most important part in any 3D print, the first layer. If you see that it's weird, that's not sticking, you can cancel it right away. There's like 0 chance of building a big statue if your first layer is a little bit off, you know. It's just, I promise you, it won't work. We've been printing for a long time now, and yeah. So with this one, Adventurer 3, we got a good example of a printing with the brim. And what that means that we build a base, you know, which helps with adhesion. That is so important when we got models which are tall and have a small surface on the bottom. So, example, you printing a pencil. There's no way it will stick if it's like this high, and you know the area it sticks is like 1 centimeter or so. So you do a brim, which later you can take off. There are many types of brims you can choose in the slicer. They usually should come off as easy as this. You can also check it, just, you know, to what it is. There you go. Ladies first. Yeah. And no, it's good, you know. I just see the audience is great that we have such a different age groups, males, females. My goal too is to be a bit of an ambassador to 3D print, where I feel like it's still very niche technology, you know, where it's only real enthusiasts in there. But I see the future where all of us are gonna be using it at home, like we use a kitchen stove. I don't even want to compare it to a paper printer, because that's obsolete, you know, that's gone. So nobody needs that. But I think a kitchen stove is perfect, where, you know, people will always love cooking, and I think people will always love building stuff. So this is like the tools which will help us do that. And yeah, through education, through platforms, we'll learn that. Okay, so I got this small brother, the Adventurer free. So likewise, now we forgot to do something before we print. Right. Spray it. Good point. Because now I didn't touch it too much, but still, you know, just the courtesy of your next guy who'll be there. Just spray a bit of that alcohol. Get a napkin, which is it's always somewhere, of course. Do we have one? Yeah. So anyway, yeah, the point is there. Yeah, good example. We're running out of filament. We could still print like one benchy with this, but for the argument, we won't. You know, we'll just take it away. And the really important thing, and that's where usually the fun of printing ends. People print one demo file, it works, and then they need to do something technical like change the filament, so on, it gets clogged, then bye-bye. Good thing these days you just need to follow the instructions. So in this case, the nozzle needs to, to heat up to 240, which melts that filament inside the nozzle, and then it automatically retracts. And what does the retraction means? In this style of printer, it's called a Bowden printer, where the extruder is not connected to the nozzle, where here is the, you see, it's direct extrusion because the motor is in one unit. Benefit of this one, that it makes it lighter and cheaper, but it doesn't work for some materials, example like flexible TPUs. So these small pieces, don't throw them. You can still use it for small prints or connect it into a bigger batch and do something good with that. So with this one, you need to cut it at 45 degree. My experience, just breaking it off works too. Just don't leave this type of like spaghetti, you know, thing, and you'll be okay. And then yeah, just follow there, and it says please insert it. We go there, and it should be in. Okay, you can hear the extruder homing. All right, so we're in, and has the internal spool holders. Also, if you guys want, you're free to come and look, and yeah. Okay, so this one too, you see it's a little bit too big, and that's where Flashforge made it weird. You know, that's only small spools work with this. It's okay, we produced a workaround, like a small spool holder. I think it was one of our members that did that, so we just keep this door, you know, because it's supposed to be like that. Again, yeah, it's not perfect. That's why we prefer Prusas, but again, for hobby style, for public places, these kind of flash forges are super, because yeah, it's just safe and it's less maintenance and so on. So if you would bet with me which one will break first, I think this one will break 10 times before a Prusa breaks. So Prusa is like a Toyota Corolla, and this is like, I don't know, your washing machine. It works, you know, for 5 years. Yeah. No, it's just, yeah, but it's good, you know, it's Samsung, let's say, right? Without much sarcasm, yeah. So we see now we got a lot of spaghetti. So this is like the best example of what spaghetti is. Yeah. Great. We can say it's over. We got it. We can say big thanks. And yeah. Then we can go and throw it in our PLA box, which there's now also a big concern about environment. So what we do, we collect all the PLA. Now it's promised that all be recycled at our local stations. It's in process as well. I see the future where this will be actually good because we can keep it. We can extrude our own filament. So the solutions are still there to come, and there's a big push as well from people and governments to recycle. So yeah, and now example, we can change the printers. So yeah, this one we can go to multi-printer, and this is cool too from Flashforge. You can actually connect to multiple machines, and a little bit of a fiddly part that you need to know the IPs of the machines, like this one. So best just to take a photo of this machine's IP, and then yeah, this one ends 132. Okay. There we go. Okay. Yeah. So we have it. For a demo, it's same thing. You know, it's benchy because yeah, it's the industry's standard benchmark. Want to see the quality and speed. So this guy can print up to 100, and we'll do that. So we can put it, slice it. Again, I just love slicing it online because it's just less fiddling with USBs and so on. And it works too. Oh yeah, and now look at that, it's magic, it's working, yeah. Like, believe me, 5 years ago this was extreme luxury. Like, to have your 3D printer connected to computer or cloud was pretty much impossible. Like, yeah, bye-bye. So yeah, this is pretty much the introduction with Flashforge for happy printing. You do this, and you go. Like, if you talk about just models themselves, there are plenty of good sites like printables.com, and so that's one from Prusa. And second best or first best, I don't know, depends what you use, is Thingiverse. And obviously everything crashes when you try to show something. Yeah. Okay, it's just this one. So yeah, so this is our couple of top places we can download stuff and print it. So it ranges from a lot of stuff like drilling tools, toys, drones, I don't know, you name it. Like things you can print these days is just insane. Like the other day I fixed my house tools, you know, with 3D print, or you can prepare for your Christmas. That's cool too, you know. This one. Yeah, so just we're approaching the Prusas. So these are definitely a more prosumer printers, and I guess that's why you guys came, you know, here after all. So yeah, this is how you remove the bed. You just flex it a bit, like don't bend it to the point where it breaks. But yeah, we're just going to show you now something really cool. Right. So, imagine like these two guys look way more fancy than Prusa. But to print that small boat, the Benchy takes them over an hour. Though for the new Prusa, you can do it in 12 minutes. Which is crazy. I mean, when I started 3D printing, okay, there was no Benchy at that time even, but like 10 years ago to print me a spatula like this used to take like half a day. Because you were fighting 10 times to make the first layer. You were fighting to adjust the bed, and so on and so on. So it was a total DIY that only crazy people were doing it, like me. Now, what's even more crazy, you can print with tolerances. If any of you are more CAD enthusiasts, I guess you know what a tolerances are. With tolerances, you can produce actually functional stuff that fit within things. And you can see in here to try like what tolerances Prusa prints. Yeah, and I'll show you now examples of like a Prusa variable layer printing. So this is a holder for my mini. Yeah, I got a thing 7 minis at home. It's a whole 3D farm. You know, I'm printing a lot of stuff. So with this one, it's a fully functional thing to hold your spool, and it slides. You see like how well it connects, and this is really precision, which is impossible to do with Chinese printers. Believe me, I had so many of them, and never it works like that. So yeah, this is a big feat where Prusa printers are actually becoming mini factories, I would say. You can actually do stuff that you can screw a screw cork on top. You can do gears. You can't print ball bearings yet, obviously, but we even experimented with metal. There are ways now to print metal on Prusas. Yeah. So other stuff that you can do, you can print actually beautiful prototypes. This is an example, a prototype of a car you can share on, and you can see a bit of the quality and stuff of, yeah. And many more stuff like bag holders, you know, example. You can just have this to hold your bag, you know. Very mundane thing that my beloved wife asked me to do, and since then it was my favorite item to print. And later I'll give out some for free as a souvenir. Or you can print a key tags, and get your keys out there with the fully functional designs. Other stuff. This is for helping the print bed. Again, a beautiful quality which was completely impossible without input shaping. That would just came to Prusa's maybe 2 months ago. We actually at Toyota were first alpha testers, because Hasiel called me and was like, "Did you try it out?" I was like, "Nah, man, we're just testing the printers." It's like, "Input shaping is out." I'm like, "What the hell are you talking about?" And I was like, "Oh, it's just like Clipper." Okay, we're now going into details. I think is Hasiel will be better at that. But what math means in human language, input shaping. If you would come here and touch the table, yeah, it's going bonkers. And we're printing a bonkers benching how in 12 minutes, but the whole table is, I don't know, you couldn't sleep on this. Like, you would be awake all day. Like, so welcome to touch it later, but 3 printers all printing at once. Imagine what's going on there. It's like a constant turbulence. And that print head really needs to be constantly where it needs to be, because if it's off, you're not printing your intention. You're again spaghetti, bolognese, all there. But what this does, it compensates. There are many ways some printers compensate it with inbuilt accelerometers. Prusa's do it with the presets. Anyway, and how to go to technical, it just knows how to counter those vibrations. That's why you get better layers, better looking products, and like that silver car. It's possible to do beautiful surfaces, which, if you asked me before, was completely not even in your dreams. Yeah. So, I think we're covering now quite a bit, and I can also show you a bit more examples, to where we're going. So myself as a car designer, it's obviously I got a sweet spot for cars. So I've been testing so many cars these days, how to make them and so on. But I was like, could we do an experiment with our audience and print something together, with hopefully with this same Prusa. So yeah, let's try it out. Hello, good evening. We're trying to make a good prompt for 3D printing.
Hey there. So you're sculpting the future with your words. What's the masterpiece you want our 3D printing wizardry to conjure up for you?
Yeah, and we'll ask the audience, what would you like to design there? You just talk to it. Okay. Okay. Yeah. You can choose, yeah, and then we'll do it step by step, you know. All right. Now we'll then choose, like, you guys will vote which one we're doing, and we'll go on with that. You know. Yeah. Yeah, got his new bot, you know, developed, and yeah.
Thank you. Yeah, so you've been showing us a lot how to print different models. What is your preferred way of creating one of those models?
Yeah, so the old way used to be we start sketching, yeah, and then from sketch we go to programs like Tinkercad or Fusion 360, which I think the best, you know, starting. So it's this one, which is I recommend for all the starters. Fusion 360 if you're like more of a engineer. And then if you own a tablet, I would definitely suggest my buddy's Istvan Shaper 3D, which is a perfect balance between advanced and simple. So, but Tinkercad is that easy that you can even start with your kids, you know? Seriously, you can do something as simple as you see there. You don't need to be like a designer like me with 20 years of experience stuff. You can just go there, and I promise you'll design something in a couple of hours. Or you can also go with help of AI. That's what I'm also developing. So do you guys now choose one object we're doing as a demo? Was it a toothbrush holder or something else? Or a coffee maker? To which one? To what else? It's on the table. You guys need to choose because we just have time for one, I believe, you know?
What was the? Because you
Yeah,
said
Aaron-
coffee maker, or
We got a coffee maker, we got a toothbrush holder, we got a...
toothbrush holder. Well, there was a bottle cap as well.
What else was there?
Yeah.
Yeah.
Okay. Oli, what would you like to see? Okay. So one was a coffee maker.
All right.
Next one was the bottle opener. Okay, and the next one was the toothbrush holder. How many for that?
Yeah.
Yeah, I think it was four for that. And how many for the coffee? Like 5. I think it's a coffee. It's between the coffee and the toothbrush holder. Yeah.
So which one? Coffee maker. Okay,
Alright.
let's see what can, let's say, Swedish coffee maker. All right, and we're just going now on the fly, just doing it. Here we go. Is that cool? Like, all right. Simple coffee maker. Here we go. We're doing a second one now. So this is just a 2D image, you know, that we're now contemplating on. Right? All right, let's test it more then. Here we go with that. All right, we got even more elegant one. I think this one is a bit more elegant. Do you guys agree? You got one at home? All right, like that. I quite like it too, actually. All right, let's see. Yeah, here we go. Here we go. Right, so yeah, we can continue doing it in the background. So the idea obviously is to produce this thing seamlessly. We're still in the pickle to do it completely seamlessly. So as you see, it takes time. But guys, meanwhile, I'm doing the magic in the background with AI. Please ask questions. You know, we still got almost 17 minutes before Hasiel joined. So I love the question just before. So please hit me with your best curiosities. Yeah.
Okay.
Right.
I saw on the Benchy earlier that
Yeah.
it had in between, I don't know how to call them, spider webs.
Yeah.
How can you battle those?
Oh, you mean this stringing?
It's next to you. It's this one.
This one.
In between.
Yeah, yeah. This is called stringing in 3D print terms. You need to reduce the temperature, or you need to bake your filament. Baking, it means putting in your own oven at around 50 degrees for a couple of hours. But usually for PLA, that's not necessary. But if it's PETG, what your bottles are made from, it's almost compulsory to do that. Because if you don't, it will be most definitely, yeah, it will be like that. Like if you zoom in, you can, this is not that bad, but sometimes stringing becomes that bad that you can't even, yeah, you know, do stuff with it. So very good question, yeah.
And I would have a second one.
Yeah, go.
For
Shoot.
the Goto 10 printers, is there like a config file for them? You know, for the slicer, like a specific one with all the default or the
Yeah,
best?
if we go back to the adventurers, it's all preset, you know. That's why I think it's good that they bought these Flashforges. It's all there. You just download Flash print. That's it. The only thing there, you need to choose the model, Adventurer 3 and Adventurer 4. It's all inbuilt. You don't need to tinker too much with anything. I see the future where you don't need to deal with that. For you, it's a bit what I'm now trying to show you with AI, where you just go with the generation and the things will print. Companies like Bamboo Lab now are pretty much aiming for that. That you could do, yeah, exactly. Yeah, we got one even there. Can try to print. We'll compare actually. Oh, look at that. I mean, it's all right, no? We can choose like, okay, this is weird now. This is what AI went and like said, yeah, you go people, we're gonna make fun of you. It's okay, we're growing stuff here. Okay, dismiss. That's pretty Bauhaus, huh? It's pretty. Okay, I think we all agree this is the closest, yeah, and it's pretty doable. Let's just go with that. You know, it's the best we got. It's GLB model, so GLB means we'll need to open it with some different software, not straight to Prusa, but yeah. So here we are. Here we are. You can do a save as 3D model. And we wanted it in FreeMF. FreeMF is definitely the future of all 3D printing, I believe. It's a very good format that yeah, just makes things easy. That everything just works. And FreeMF instead of STL, because like STL is the old format, it has your measurements to see if we got a STL, we can instantly open it in the slicer. Oh, and by the way, we got our 12-minute benchy out there, which is pretty much now I think a world record. And yeah, it's a benchy. I mean, it's a boat. You can evaluate it, and I believe it's a boat. It's done like 10 times quicker than a Chinese printer would do. So yeah, I left a lot of marks there again, so we need to take care of that. Believe me, 99% of the failed prints are due to your own fingerprints. It's crazy, like how many times I've been blaming hardware, blaming gnomes, Santa Claus, or anything, just cleaning it. You see any fingerprints, clean it, then you're happy. Okay, in his case, I'll use USB, which I hate, but just because I'm not part of Goto 10 network, and yep. Uh-oh. Okay. We need to just import it as a model. There we go. So guys, what do you think? Is it a coffee maker or what? All right. Yeah, that could be that too, you know. No, but we just witnessed as well history in the making. We just designed this with you guys. What, it took us 10 minutes? No? Well, before, this would have taken us a long time, believe me. Even this type of presumably simple model would have taken us pretty long time. Okay, let's see, like, we got over an hour left, yeah, for this event. So let's aim to print it till the end of that, so we can all enjoy our creation. What is that now? That's like 2 hours. Way too much. Black? Now it's a good point, you know, now multicolor printing is now a big thing. We have those machines like Prusa XL and so on. We didn't bring it because of, you know, just managing printers. I'm alone today. Hopefully in the future we can have more people, or just workshops, you know. I would say the future we're enthusiasts, we can sit here over the weekends, bring like, I don't know, 20 printers, don't burn the house, yeah, but just go crazy, create, exchange, tinker. I think Julia and Haran are very supportive on such hackathons. So please don't be shy to propose anything like that. Yeah, so there we go. The question, will it print without supports? Because you see, it has the overhanging things. So I would suggest let's make it smaller and let's enable some supports. Supports are the things that help us, you know, the way printing works, we would love it if we could print it so there's no overhanging stuff. There are now experiments and there are expensive printers where you don't need to care, but for most FDM now we need to care. And these green parts that you see are the supports. And we're now in the 50-minute region. And yeah, we even gonna get this awesome handle to be there, you know, which is awesome. So what do we name it? Coffee maker. Some fancy name? No, go to 10. Yeah, obviously go to 10. And who was the first to suggest it? What's her name? Ferigo? Oh, Ferry, okay. Let's go, Ferry, yeah. We all have complicated names these days. I'm trying to get better, but believe me, I'm confusing and a lot of things. Yeah, always press eject drive. Won't believe me how many of the hard drives I burned while pulling it out.
Isn't there still some? Sorry, isn't
Yeah.
there still some weird stuff going on in the background? That is.
Which one? Yeah,
I have to
please show.
like these parts here.
Yeah, they're very small artifacts which will just for the demo day will with good eye, you know. I love it when I get it's perfect. Like in the ideal world, you know, when you have all the time in the world, I will go and clean this up in 3D and programs like Mesh Mixer. So it's highly recommended to get a thing called Mesh Mixer. Yeah, it's discontinued software from Autodesk. It's numbered 1 for sure, but now just these small spots, they will print. Print head will get a little bit dirty, but you know, we're trying to make a miracle in here, which on the previous event we promised this to kids, you know, and instead we gave them toys for Halloween. The kids were excited, moms were not so excited, so now we're trying to make, you know, us happy at least on this one. So yeah, beloved moms, if you're watching, we're doing the right thing now. So yeah, here we go. Where's our coffee maker? Okay, I don't see it. Maybe we need to save it second time. There we go. Let's double check now. Okay, should be there. Let's just copy it to a new folder so it's easier to find. Let's just name it Goto 10 as well. yeah, and I think in 5 minutes we're gonna have our esteemed guest joining too, right? So that's when you guys can actually ask the tough questions, and don't be shy as well. He promised me to get some Prusa swag for you as discounts for Prusa printers. So yeah, here we go. Go to 10. Okay, and that's weird. And it's not reading it. That is very strange. Okay, let's try to... yeah. So anyway, if Thijs still will join, I'll work in the background to make this happen. So, I mean, we must. So yeah, this happens too because we're working with some alpha, beta softwares. So it's just natural this happens, yeah. Because we're testing like the latest technologies, and you know, it's just what it is. It is what it is. And like our so what we'll do now as well, we'll enable the supports everywhere, so it covers the whole thing, yeah? So in this way, every little detail will print out there, and hopefully, yeah, this will make us a good difference. So there is a difference between enabling supports for only the bed and for enabling it for everything. There's a big difference. All right, let's see now. Is it better? I think it's better because see, before it was some kind of weird BG code. Okay, who knows? We can ask Hassel, what the hell was a BG code? All right. Yep, we're in the game. So 1 hour, we should have our own personal 3D printed coffee maker prototype right in here. And this is just a glimpse for you how design workflow is. You know, we sketch, we do prototypes, and then after a lot of R&D, the product is born, which you buy at the shops. And with this technology, we're pushing the time from weeks to hours. Yeah, please shoot.
Thank you. So the green part of the 3D model, will that be of the more porous?
Yeah.
And then you will just remove it yourself when the...
Yeah, with
print is
this
finished?
some grapples, yeah.
Oh, okay. And
I'll
a
show you.
follow-up question to that. We talked about the recyclability and the environment before. Is
Yeah.
it possible to recycle printed material? Or
Yeah,
is
absolutely.
that's okay.
Most of these thermoplastics, it can be reheated as much as you want without pretty much losing. That's why you see, I'm telling you, collect the trash, because probably in the very near future you can reprint your supports. You can already take your PETG balls. There's a smart cutting tool where you just take it from the spool and you do filament. So if you really have time and handy, you can make your own filament at home from your bottles. It's super easy. It just takes time, you know. So, yeah.
Yeah, thank you.
Yeah. You're welcome. All right, so should we join in with how do we do that? Sure, on Teams. Okay. Okay.
Just a thing.
Okay, I think we need admit. Wait, we need to admit. Yeah. Yeah. Hello, hello. Wait, we can go to here. One sec.
It's
Yeah.
yeah, that one there. Yeah, and the same for the video as well. So that's audio settings. Now go to video settings and go to. Oh, it doesn't give you the option.
Yeah, we're just joining you in.
Should give you the
Wait,
another option.
wait, I'll just share that so you can see us. Hello, hello. 1 second.
Audio.
I can see you guys now.
Say something, please.
You are muted.
Okay, that's good. Yeah.
I cannot.
Hello. Yeah. Good.
Okay, perfect.
Muted. We're just okay. So you can just be on there, and I'll just. How do I make Hassel full screen? Pin for me. Fit to frame.
Maybe top right.
Yeah. Spotlight for everybody. you can.
Or just double click maybe on the phone.
Okay. All right, I think let's just go with that, and yeah, I think let's just continue. All right, I will just pin the computer to the audience so maybe Hasiel can see what a great bunch we got in here. Yeah. So.
Hello, everybody.
Yeah. Hello. We're so
Hope you're all having a
stoked
good
to
night.
see you in here. We introduced the Prusas. We got one Prusa actually printing AI generated coffee maker, and this just happened after doing a 12-minute benchy.
12 minutes. Okay, that was pretty fast.
Yeah.
I'm sure you're tweaking something there.
Yeah, hacking stuff, you know. You taught me. You taught me that. All right, so stage is yours, Hasiel. The people are very curious, asking a lot of tough questions and stuff, so go ahead.
Excellent. So I'm not sure how much into detail you've gone into 3D printing and how people can get started with 3D printing, but I actually prepared a presentation for everybody tonight. And first of all, let me thank you for having the space to talk to you today. And I am deeply sorry I could not be there in person. The original idea was for me to actually fly out to Sweden and give this talk live and answer all of your questions live. But it was quite unfortunate that I actually caught COVID during Formnext a couple of weeks ago, which was one of the biggest additive manufacturing events in Europe, in Frankfurt. So I guess the online session will have to do for this time around. And I will be just sharing my screen and maybe talk to you about a little bit about 3D printing. So I'm not sure if...
Cool. Don't forget the freebies and the discount codes too.
Sure,
Yeah,
absolutely.
People were super excited about that too. So yeah.
Definitely, I'll talk to them about that towards the end. Let me just quickly try and see if I can share my screen here.
Yeah, and generally, I think we introduced the crowd to 3D printing. They seen how benches are made. We showed filaments. So we got ABC, definitely.
Okay,
They
excellent.
know that MK4 is now the king too.
Excellent. So I'm gonna try to share this screen. Can everybody see this?
Totally.
Excellent. So again, thank you for just giving me the opportunity to talk to you about what we're doing a little bit in Prusa. And well, this presentation is called Accelerating Your 3D Printing Journey from 0 to 60. So the whole objective of this presentation is just to give you a brief background on how you can get started into 3D printing, and maybe what are some of the capabilities that you can do yourself. And also going from 0 to 60, I will be sharing some of my kind of like my own journey of where I got started and how you can apply some of these concepts and some of these steps into your own journey to go from 0 to 60 with 3D printing. So we'll go through some slides, and towards the end of the presentation, I'll just open up for a Q&A session. You can ask me anything that you would like, and yeah, we'll get started. So I just wanted to quickly take you through kind of like the story behind 3D printing, how it got started, and of course, 3D printing has now experienced exponential growth throughout the years. And it started out as a very niche technology, and it went from niche technology to mainstream. So mainstream meaning that the normal consumer was now driving the innovation across various industries. And actually, back in the 1980s, this technology is this old. It started out in the 1980s by the first patent that was issued by Dr. Komoda. And he was actually he was researching on how to do rapid prototyping back then. And he developed a technology called stereolithography. Stereolithography, the easy way to understand it is like your home printer, where you print out maybe a picture or maybe your tax return or something like this. You know that on every single layer, or it adds a layer of resin to basically print out the lettering. So imagine this, but you just do it over and over and over again, over an extended period of time. And you use UV light to cure it. So this was the very first 3D printer, believe it or not. And this was back in the 1980s. And ever since, we've come a long way. So in the 1980s, there was a huge boom in this technology, stereolithography, but there was also some other technologies because of this. Other people caught wind of this and started to come up with their own technologies. So the 1980s really saw a big boom in the developing different types of technologies of 3D printing. So there's several. There's many out there. So for example, in the 1980s, there was also something called SLS, which is called selective laser sintering, meaning that you take some powder and you cure it, or you sinter it with a laser. There was also fused deposit modeling, which is the most widely used these days, which is the big mainstream. Of course, Prusa Research also does FFF, fused filament fabrication. We cannot use fused deposit modeling because back in the 1980s, the biggest company, Stratasys, patented this name. So we just gave it a different name called fused filament fabrication. But across the years, there were some other companies that started to research some other technologies like digital light processing, multi-jet fusion by Hewlett-Packard, HP, SLM, which is selective laser melting, EBM, electronic beam melting, DMLS is direct metal laser sintering, and the list just goes on and on and on. So I guess what I'm just trying to explain to you is that there's not just a single technology in 3D printing. There's various ones, and each of these has its own benefits for a specific type of applications. So fast forward from the 1980s until 2023, and now we have a Stargate 4th generation, which looks like this. So 3D printing has definitely come a long way since the 1980s, and basically this Stargate 4th generation is a huge printer that's printing metal parts. As you can see, it's quite colossal. So you might wonder
Hassel, we're still on the first slide. We were just being polite, but now we're trying to understand that your slides are not moving. Okay, yeah.
Can you see this now?
Now we're moving. Yeah, now we see the computer in 1980s. So
okay.
Yeah. Don't worry. We're good. We're good.
Let's see. Can you see the slide now? The 1980 slide?
Yeah.
Okay, so this was the first 3D printer, and please feel free to stop me anytime that the slides are not working.
Absolutely.
So I can kind of make sure that I'm just not talking to myself.
Yeah. Thank you.
And so this was the SLA printer, and these were the several types of technologies that I was mentioning. Selective laser sintering, FDM, and this is the Stargate 4th generation that was announced this year, 2023. So I will switch to another slide. Let me know if you can see it.
No.
Yes? No?
I think once you press it on that side, it switches, but like that. Yeah, now it switched.
Okay, so I guess I will just have to, or maybe.
Yeah. I think you just need to go manual.
Let me try to do something a little bit different.
You're back.
Sorry.
It's all right. We're all good.
Okay, let's try to share a different window. Let's see. How about this? Does this work?
Yeah, it's now even full screen. Though it's
Okay, excellent.
yeah.
So let's go back to this slide. So I think I left off here at the fourth generation Stargate 3D printer. And this Stargate is used on the Falcon 9 rocket to basically print out the rockets, the metal rocket parts. So I guess the biggest takeaway from this is that 3D printing has a wide range of applications across sectors, right? So it has expanded its applications across many sectors, such as healthcare, aerospace, automotive, consumer goods, and the list just goes on and on and on and on. I guess the best way to understand it, if you are a normal person in this hectic world, and you own something like a normal person, then probably that piece of thing that you own was at some point either it was used, 3D printing was used to prototype it, or 3D printing was used to actually manufacture something. So, you know, even telephones, computers, everything pretty much goes through an additive manufacturing process, I guess. So now that we kind of know a little bit about the history about 3D printing, where it came from, so what exactly is 3D printing? And I'm hoping that Thomas already covered this and has already explained to you what exactly it is. So I'm just going to give you a quick overview. So in very simple terms is building objects layer by layer from digital models. So I guess this is the perfect picture to understand how the technology actually works. So you have a nozzle, which is heating up a material. In this case, it's heating up the plastic, and it's depositing this melted plastic on top of a bed or a table, and it's doing so layer by layer. So it goes one layer, second layer, third layer, fourth layer, until you get the full 3D digital model. So that's basically what 3D printing is called, and it is actually called this process of putting layer by layer. It's called additive manufacturing. So additive manufacturing is actually the industrial term that we use internally. We don't really call it 3D printing. It's actually additive manufacturing because you're adding layer by layer. So you're adding material to make something, as opposed to some other technologies like CNC milling, which is actually subtracting material, which is subtractive manufacturing. So additive manufacturing. So what are the basic principles involved in this? So as I mentioned, you're basically making an object out of a digital design, right? So you have your digital design, and you can make this either through a CAD program. So if you can, so if you have access, or if you have engineering skills, or if you have designing skills, you're basically used to working in a CAD program. Or there's another option. You can also go to some repositories where they already have ready to use models for you to just download and print. So that's another option. Or you can always ask your friend, if you have an engineering friend or somebody that is a little bit well savvy with CAD software. They can make you a digital design of pretty much anything.
Right.
So,
or to actually miss the part where we design the coffee maker with help of artificial intelligence.
Exactly. Exactly. This is another topic that Thomas has been discussing, and I'm sure you'll get to hear more about this. What's around the corner is actually being able to through AI just type in or say what exactly it is that you want, and once the AI engine processes it, it gives you a 2D image and turns this 2D image into a 3D model, and this 3D model you can later basically download as an STL file and 3D print it essentially. So I'm sure Thomas has explained to you how this technology works, or he'll get to it maybe later on in the session. But that's another, that's what's coming around the corner basically in a few years. So from this point, once you have the digital design, a 3D model, so now you have to make a material choice, right? And the material, why is it important to choose the right material? Because each material has its own unique properties. You might have to find the right application. So for example, the right material in the healthcare sector, it's much different than the automotive sector, because in the automotive sector you might require something that can withstand high temperatures, something like a polycarbonate carbon fiber, or in the health sector you want something that's maybe antimicrobial, that has antimicrobial properties, or can be basically can be put in one of these machines that sterilizes the instrument. So in order for you to do that, then you need to be printing out with very, very advanced materials, kind of like aerospace grade materials. But for your typical applications, you can choose something like PLA or PETG, which are like the most common materials to use. PLA, polylactic acid, is actually it comes from bio sources. So it comes from corn, it also comes from sugar cane, etc. And PETG is polyether terephthalate, polyethylene terephthalate glycol. And this is basically what you see most on the Coca-Cola bottles, on your normal everyday bottles. If you ever buy a water bottle at the gas station, you're basically drinking out of PET. So the material choice is very important, because it will also tell you, or it will also determine the parameters that you have to set for the next stage, which is actually the slicing. So whenever you buy a 3D printer, you also get a slicer program with this. So the slicer program, what you'll be able to do with this is input parameters such as the temperatures, the speeds, etc. So it's very important to first know the material so you can use those parameters in the slicer. And what the slicer does is exactly what its name implies. It slices the object into layers. So it takes that digital design and puts it into 1,000 layers that you can print. And it does this by utilizing G-code. So the G-code is basically the language that the slicer generates so that the 3D printer can utilize to 3D print the object. So the G-code is only basically the language of the coordinates in the sheet, telling it where to go at what time, with what speed, with what flow, etc. So it's just basically utilizing that language. And finally, well, we come down to the layer by layer construction, which is actually the 3D printing, right? So now you have your object and you 3D print this this digital model, and that's basically the principles. So I guess we can print out a rocket now, right? We can print out one of the Falcon 9 rockets, since we already know how to utilize all this. Well, not exactly, because this was actually one of my first rockets that I 3D printed. And like I said, with anything that you're printing, you have to find the right application with the right materials. So going from polymer 3D printing to metal-based 3D printing, that's a huge step. So what I'm trying to convey here is that there's always a learning curve, right? So 3D printing has a learning curve like anything else out there. If you're going to learn a new language, you have to go and learn the basics, the vocabulary. You also have to learn the grammar structure. It's the same thing with 3D printing. You have to dedicate some time into learning the digital design. For example, if you want to learn a CAD program, you have to learn a little bit about the materials that you can use. You have to learn some things about the slicing, how to work with it, and you actually have to learn how to properly 3D print an object. And I like to describe the 3D printing learning curve like this. So that is the 3D printing learning curve, at least in my view, because you will go through some struggles at the beginning. And a lot of people will not make it along the way, but for those few that do, the grass is always greener in the other side of the road. But please, this is just a cute example of the learning curve, but don't let this learning curve discourage you from actually starting to 3D print. And the reason for this is because the learning curve actually looks something more like this. So this is a personal example of how I started or how I got started into 3D printing. And I started basically with this, with the same technology like Dr. Komoda started with, which is stereolithography. This was one of my this was one of my first pieces that I tried to 3D print, which was horrible. It did not print. I failed many times. However, I kept at it. I kept working. I kept learning the concepts, the principles, and I went now today to 2023. I can do things like this. So this was actually a robotic gripper that I recently printed out in Form Next. Thomas got to see it live in person.
It looked awesome.
So this is a lightweight additive manufacturing robotic gripper in collaboration with Siemens. Basically, you can mount this gripper in a robotic arm. At Prusa, we have a use case where we have to take boxes from one place and stack them up in a pallet. So we went through the entire process of identifying the use case, doing the design, doing some form of simulations as well. So running some FEM analysis to make sure that it could withstand the pressures, choosing the right material, and later on we determined that it was the right topology with the right material. It was able to withstand 84 kilograms of weight with 59 megapascals of pressure, and then we went on to actually 3D printing this and basically mounted it on the UR10 robot for its application. So, and this was all done in a Prusa printer. It's you don't need to have some of these Stargate technologies to be able to accomplish these things. So that's what basically the learning curve looks like. So I guess the biggest takeaway from this is don't be discouraged by this because it doesn't really look like that. It looks a lot exponential, a lot more exponential. And don't take my word for it. I mean, I'm just a guy that's starting out in 3D printing, basically. I haven't been around. Since 2017, I started to 3D print. But I understand that these applications have been around for much longer, and companies such as Siemens, for example, are doing crazy stuff with Prusas. For example, 3D printing an entire robotic actuator for carrying the battery packs of an automotive company. So everything that you see there in orange was actually 3D printed in an MK3S Plus, which is the previous generation 3D printer. So you can utilize this technology in many forms. Okay, so I guess now the question is, how can I go from 0 to 60 and basically apply the same principles? Well, first of all, you got to get a 3D printer because if you don't, you cannot print. Second of all, you have to start printing some benchies, and benchies are basically this. These are the benchies or boats, and what these benchies are is just basically giving you a benchmark for the material settings that you're using, the speeds, etc. And basically, this is my wall of benchies over a period of 1 year now. So as you can see, there's quite of them there. And step number 3, print more benchies. So that's the way to get from 0 to 60 into 3D printing. But be more realistic. The more realistic 0 to 60 starts out like this. So what I would recommend is first learn some CAD programs. Or if you don't want to go through that learning curve, there's always these repositories that I mentioned before, where you can easily download these STL files, and you can basically just download them and start 3D printing. So at Prusa, we have what's called printables.com, which is a repository of 3D files of pretty much anything that you can possibly imagine. If you have a coffee maker at home, more than likely you'll find something on the internet that you can add an addition to it. If you need something for the TV, for, I don't know, for a Christmas present or something like this, you'll be able to find something in printables.com that you can print, if you're not willing to go through the learning curve of learning a CAD program. So the second step is learning about the materials. So also at Prusa3D.com, we have a section where we have a material database, and it's a basic sheet, which is the one that you see here. And it just gives you information about the different properties of the material, whether you can print it on certain settings, on certain sheets, etc. So this is pretty straightforward and easy to learn. Doesn't require that much to get started. Third, the step 3 is actually learning some slicing principles, because you will need to interact with this software in order to slice the objects. And we have a wide range of courses in Prusa3D.com, which is called Prusa Academy. It takes you through basically the entire 3D printing process, from the 3D printing basics, and these are basically some of the ways that you can get started very easily to learn these concepts. There's also a huge community around it. There's always the help from our website, and we have several YouTube courses. So just what I'm trying to say is you can start getting involved into slicing through all of these resources. Step number 4, I guess it would just be print, right? Get involved in the community, print more, and if you fail at your first print, well, any failure is a learning opportunity for you, and I guess you can continue on your journey there. So now that we kind of know what are the steps that you can take in order to get into 3D printing, it's also very important to choose the right 3D printer. Now, I'm not saying this because I work for Prusa Research and I'm recommending the MK4 kit, but I am kind of recommending the MK4 kit. And the reason is for this. If you really want to understand how a 3D printer works, what are the nuances, what are the how you can repair it, I definitely recommend getting a kit, because you will build it from start to finish, right? You will just get a whole bunch of parts and you will get an entire guide showing you how to do it. Usually you can build this printer in about 8 hours. So you can go through the entire learning curve of how to actually build a 3D printer, and this will be very valuable for you because later on you'll know how to service this printer, and you'll become more. It's a learning opportunity of learning the various aspects of what each component does. So I definitely recommend the MK4 kit.
Yeah.
And finally, I just wanted to quickly mention what we're kind of working at Prusa, so what's next for us. So personally, I don't think I actually introduced myself at the very beginning, but I guess I'll take the opportunity now. My name is Jaciel Trujano, and I am the Key Account Manager for Prusa Research, and specifically for this product that you're seeing here, which is the automated farming system. And as the name implies, it's automation, what's coming around the corner for 3D printing. So everybody wants to basically do hands-off and just start printing without having to interact with the machine anymore. So without having to go and bend the plate, remove the print. So that's basically what we're doing with the Prusa AFS. It's basically automating the entire process from start to finish. And hopefully next year we'll have the full release of this product, and you can find out more about this at prusaafs.com. And also we're working on some other interesting products. For example, the one on the left, which is the HT90. This is a high temperature 3D printer. It's in a different configuration. This is what we call Delta configuration. And with this particular printer, you can print more advanced materials like polyether ether ketone, or not polyether ether ketone, but ULTEM, which is a polyether ketone. So it's an aerospace material that can withstand high corrosiveness and high temperatures as well. So that's what we'll be releasing out next year. And also to the left, we have the SLX, which is kind of like the same technology from what we saw at the very beginning from Dr. Komoda. It's an SLA printer, a stereolithography, just on a larger configuration. And I guess that's it. So thank you very much for taking the time to listen to this presentation. And I guess I just wanted to finish out with this. If you are interested in getting to know a little bit more, getting yourself more into 3D printing, you can send Thomas an email with the keyword "KitMeNow," and basically we will offer you 10% off the MK4 kit. We will give you a free filament, a free Prusa hoodie, and you will have access to the Prusa Academy, to all its courses, so you can get started in your 3D printing journey. So thank you very much.
Ooh, that's
and
amazing.
I'm open to questions now.
Yeah, that's great, Hasil. I think me and Huli will handle this somehow in a team, because I think it's Uli who has all the emails and can update the guys. Otherwise, yeah, you just post me up. We're always excited to welcome new enthusiasts, and that's what it is. It's like, why Hasil is not lying to you that MK4 or Mini is the best way to start, which also I need to mention. Mini is the smaller cousin of MK4, because this technology is still in its baby stages compared to, I don't know, cars or washing machines. It's any printer on a market that you buy, you'll need to fix. The difference is, if you buy an expensive Chinese printer, it breaks down and you need to throw it in the trash bin. With the MK4s, it's a Czech build, the European product, which is very conscious about reusability, upcycling, and we want to keep it going. I think there are MK2s that are running now for what, 10 years now, or? Correct
Exactly.
me. Yeah, so
10 years now.
yeah, so I promise you, there is no printer that you just buy it and print. This is not the kind of hobby. This is the hobby where you always need to fix stuff, improve it, and because the whole industry is still moving at a light speed. It's like I mentioned you benches. Just 1 year ago, it took 2 hours to print a benchy. Now we printed it in 12 minutes. So it's unbelievable what's going on here. So yeah.
Absolutely. Do we have any questions from the audience? I'd be happy to answer anything.
Yeah. Pass you over.
Hi, yes, I have a question. Do you hear me? Yes. You talked about automation. How can we imagine that? Like, what does the machine do? All does it clean itself? And I don't know. Like, could you elaborate a bit on that?
Sure. So the whole thing behind automation is we saw that the industry. Imagine these companies that have a farm of 3D printers. So you have maybe 50, 100 3D printers. So the biggest challenge of actually managing this farm is to have the workforce that goes and clicks on the button, starts the print. When the print is finished, takes the print out, removes it from the plate, and then has to sort it into whichever production line they have, right? So that's what actually takes a lot of effort, and for some of these countries, it's also very expensive to have a lot of people doing or servicing 100 printers at any one time. So the whole idea behind this is to eliminate the entire need for somebody to actually have to go manually and press click to start the print, go and remove it from the plate. So this is what we're actually automating. So the automation, it comes in two manners. It comes in the manner of the hardware and the software, because you cannot automate one without the other. In the hardware, some of the things that have to be automated is the way to take the sheet from the printing basis and basically take it into a place where they can be, the print themselves can be removed, and then this sheet goes back into the printer. So that is accomplished with a robotic arm. So that's part of the hardware automation. And also there's some other elements that we're automating on the hardware, such as like the shelving functions, which is basically just taking the sheet and putting it in a shelf. So later, maybe on the weekend, somebody can, or on Monday after the printer has been printing over the weekend, they can come and take those sheets and remove them. For certain applications, you want to do this because maybe you want to do some form of serialization on the part. So it just depends on the application. So that's some of the automation for the hardware, and automation on the software. That's also very important because we have to find a way how to tell each printer to start a job, and also we have to find a way to basically be able to receive jobs automatically. So for example, let's say you're in Sweden right now and you're on your phone. You find a piece that you want to print, and you can just basically click print via your phone. So what that's going to do is going to send out a notification to the AFS, which is, for example, in the Czech Republic, and it's going to tell, okay, well, there's somebody that wants to 3D print this specific part, and it queues it up in the system and basically starts the print once its queue is once it's in line next in queue. So basically you're automating all of this process as well, and that's one of the key factors for companies these days, that they can just start a print somewhere in the USA and have the manufacturing somewhere, for example, in a country like Portugal, which actually is in terms of nearshoring, it gives companies a lot more flexibility in this manner.
Okay, thanks. And maybe a second question: what are what is a typical product that is produced in one of those farms? Or like what kind of things are printed?
Any kind of product. I mean, it largely depends on the companies that will be purchasing this automated farm system. But for example, some of the parts that we have seen are prototypes, such as the part that I actually showed you, the robotic gripper, was actually manufactured on the AFS. So you can go from something very technical to something very simple, like like that little piece of rocket that I also showed. So it just depends on what you want to 3D print. The applications are far and wide, and the materials options are also. I guess that's more a limiting factor for the machine, because it can only print up to maybe a polycarbonate or a nylon. We cannot print more of these advanced materials that would require a heated chamber, because the AFS does not have a heated chamber. So I guess the limitations are more on the material side rather than on the particular components that you can print.
All right, thanks.
Yeah, I heard that you went from 2 hours with the Benchy to what we saw now, 12 minutes. Do we see a future will be 2 minutes in a couple of years, or where do you think that the threshold for 3D printing speed would lie?
Well, actually, that's a very good question, because there's this sub community out on the internet that is called the Voron Challenge, that are doing 3D printing speed boats, speed benchies. That's what they call them. And right now, I think somebody holds the world record at less than a minute. I think it's about 1 minute and 30 seconds, which has some acceleration of about 3,000 millimeters per second. So just to compare it, right now the MK4, the one that you have there, or the one that you have in front of you, is printing somewhere around like the 300 millimeter, maybe 400 millimeter per second. And we're talking about 2,000, 3,000 millimeter per second on the speed benches. So I guess the biggest limitation to this, it's not really on the hardware right now, it's on the software. Because we have to find new and clever ways to compensate for the acceleration and deceleration. And also we need to find better ways to, new technology has to be evolved to compensate for the flow of material that is being pushed out of the nozzle, which is another big limiting factor. But I would say that in a few years you could definitely see about 1,500 millimeters per second being printed on industrial machinery. Right now it's already being done at 600, 700 millimeters per second.
Okay, thank you.
That's awesome. Hassel, I saw the Prusa MK4 limit is 600. Is that correct?
Yes, and that's assuming that you're probably printing on PLA. Because, you know, of course, depending on the material, you don't want to print a TPU at 600 millimeters per second. You want to go very, very slow, because TPU has a different density, and it will just be a mess. So yes, that is accurate, but it's assuming that you're doing PLA, polylactic acid.
Awesome. All right, so someone else. I mean, you guys also just welcome, you know, to walk around, look at the stuff from close by, and inspect stuff. So I'm very encouraging that too. Yeah, and
So I guess I have a question for the audience. So who has experience in 3D printing here? Who has ever 3D printed? Has anybody? You? Okay, one person.
We have one.
Okay, great.
Two.
okay.
Great. So who's thinking about 3D printing?
Yeah, we have most everybody.
Okay. And my last question for the people that are thinking about 3D printing: what's stopping you?
Yeah, for me personally, it is building the actual model to 3D print. So I have a thing in my mind that I would like to 3D print, but I don't really know how to make it into reality.
Okay. I mentioned earlier that we have these repositories like printables.com. So I would highly encourage you to visit printables.com, and you can find many, many models there that you can browse through and download for free. They're free of charge. These are models that the community makes, and specifically, if you find a designer there that you like, you can always message them directly and ask them, "Hey, can you build me this?" And most of the time, these are great people, and it's a big community, and they'll probably agree to make something for you free of charge. So I encourage you to check out printables.com. So there's no reason why you shouldn't 3D print now.
And there was also this CAD program that Prusa provided, or
Prusa provides the slicer.
only right.
The slicer. So if you want something like a free CAD program, I would recommend Tinkercad. Tinkercad is a free-to-use cloud CAD software. Very easy to use, and it's very, very simple and easy to get into. So I would encourage you to check it out as well.
Thank you.
Yeah, also, as you saw, I'm building a workflow where artificial intelligence can help to realize your dreams, and our coffee maker is almost there. It's at 78%. And like we spoke, we're still a little limited to visual prototypes, but I'm very strong believer that once we connect large language models and CAD programs, which actually we discussed during Forum Next with Siemens and Autodesk and all the big players, and they were like, yeah, it's becoming to reality. We want to see that. And I was like, all right, let's buckle up.
Thomas?
Yeah.
So I'm just gonna have to step out because I have to catch a bus.
Yeah. No
I have to
problem.
catch a bus home.
Yeah.
I'm actually in Prague today, and I have to go back home to Bratislava. So
absolutely,
it was nice to be here. Thank you all for taking the time to listen to me. And if you're interested more in 3D printing, please be sure to send keep me now to Thomas, and we'll get in touch, and we can get you started on your 3D printing journey.
Thanks a lot.
Thank you, guys.
Thank you.
Yeah. Bye-bye.
Bye-bye.
All right. So this was Haisel Trujano from Prusa, guys. Right. Okay. So I guess we're shutting it or like keeping.
So you're off stream now, yeah?
Yeah, I think